The National Electrical Code, or NEC, has specific requirements for the placement of battery chargers to ensure safety and mitigate potential hazards. NEC Section 511.3 states that battery chargers shall not be located in the same room as the batteries they charge. Additionally, NEC Section 511.10 mandates that battery chargers shall be installed in a location designated for that purpose and suitably ventilated. The primary reason for these regulations is to minimize the risk of hydrogen gas explosion. Hydrogen gas is a byproduct of the battery charging process and can be highly explosive if it accumulates in a confined space. The placement of the main distribution panel, or MDP, is not directly relevant to the NEC requirements for battery charger locations. The MDP serves as the main electrical panel for the facility and does not inherently pose a risk to battery chargers. When considering the location of battery chargers, several factors should be taken into account. Firstly, battery proximity is crucial. While the NEC stipulates separation between battery chargers and batteries, it does not define a specific minimum distance. A distance of approximately 20 feet is generally considered reasonable, allowing for adequate ventilation to dissipate any hydrogen gas that may be produced. Secondly, ventilation is paramount. The area designated for battery chargers must be well ventilated. This can be achieved through natural ventilation, such as open windows or vents, or through mechanical ventilation systems designed to circulate air and prevent the buildup of hydrogen gas. Thirdly, accessibility is important. Battery chargers should be easily accessible for routine maintenance, inspections, and repairs. Ensuring easy access helps facilitate proper upkeep and timely identification of any potential issues. Fourthly, clearance is essential. Sufficient clearance around the battery charger should be maintained to allow for proper operation and maintenance activities. Adequate space ensures that technicians can safely and effectively perform their tasks without obstruction. The amount of hydrogen gas generated during battery charging depends on several variables. These include the type of battery, the charging rate, and the ambient temperature. Lead-acid batteries, for example, tend to produce more hydrogen gas compared to other battery types. Moreover, higher charging rates and warmer temperatures can further increase the production of hydrogen gas. While the production of hydrogen gas is a significant concern, the implementation of proper ventilation and separation measures can effectively mitigate the risk of explosion. The NEC requirements for battery charger locations are specifically designed to ensure the safe dissipation of hydrogen gas, thereby preventing hazardous conditions. In conclusion, locating the battery chargers within 20 feet of the MDP and a BP in a warehouse is generally acceptable, provided that the designated area is adequately ventilated and offers sufficient clearance for operation and maintenance. This location strategy aligns with the NEC requirements for battery charger separation and ventilation, ensuring that the risk of hydrogen gas accumulation is minimized. Furthermore, the proximity to the MDP does not present any specific hazard, as long as all electrical connections and installations are performed in accordance with applicable electrical codes and standards. It is always recommended to consult with a qualified electrical engineer or inspector to ensure full compliance with all relevant regulations and to address any specific concerns related to the installation and operation of battery chargers in the warehouse environment. Always verify the latest edition of the NEC and local regulations, as codes and standards can change over time. Understanding electrical concepts such as voltage, amperage, and resistance is crucial for electrical safety and proper installation. Voltage, measured in volts, is the electrical potential difference that drives current through a circuit. Amperage, measured in amps, is the rate of flow of electrical charge. Resistance, measured in ohms, opposes the flow of current. Understanding these concepts helps in selecting the correct equipment and ensuring safe operation. Electrical circuits are governed by Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. This relationship is fundamental in designing and troubleshooting electrical systems. When working with electrical systems, always use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. This helps protect against electrical shock and other hazards. Regularly inspect electrical equipment and wiring for any signs of damage or wear. Damaged equipment should be repaired or replaced immediately to prevent accidents. Grounding is an important safety measure that provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Ensure that all electrical equipment is properly grounded. Circuit breakers and fuses are overcurrent protection devices that are designed to interrupt the flow of current in the event of an overload or short circuit. Make sure that circuit breakers and fuses are properly sized for the circuits they protect. Electrical panels should be kept clean and free of obstructions. Clearly label all circuit breakers and fuses to facilitate easy identification and troubleshooting. When performing electrical work, always de-energize the circuit or equipment before starting. Use a voltage tester to verify that the circuit is de-energized. Follow lockout/tagout procedures to prevent accidental re-energization of the circuit. Proper wiring techniques are essential for electrical safety and reliability. Use appropriately sized conductors for the circuit and make sure that all connections are tight and secure. Avoid overloading circuits by connecting too many devices to a single circuit. Overloading can cause the circuit breaker to trip or, in severe cases, can lead to a fire. Be aware of the dangers of arc flash, which is a sudden release of electrical energy that can cause severe burns and other injuries. Wear appropriate arc flash PPE when working on energized equipment. Regularly test ground fault circuit interrupters, or GFCIs, to ensure that they are functioning properly. GFCIs are designed to protect against electrical shock by detecting ground faults and interrupting the flow of current. Use surge protectors to protect sensitive electronic equipment from voltage spikes and surges. Voltage spikes can damage or destroy electronic components. When working with three-phase power systems, ensure that the phases are properly balanced. Imbalanced phases can cause overheating and damage to equipment. Use a multimeter to measure voltage, current, and resistance in electrical circuits. A multimeter is an essential tool for troubleshooting electrical problems. Follow all applicable electrical codes and standards when installing and maintaining electrical systems. Electrical codes are designed to ensure safety and prevent electrical hazards. Regularly inspect electrical systems for any signs of overheating. Overheating can indicate loose connections, overloaded circuits, or other problems. Use infrared thermometers to detect hot spots in electrical panels and equipment. Proper ventilation is essential for electrical equipment. Overheating can damage electrical components and reduce their lifespan. Ensure that electrical equipment is properly ventilated to prevent overheating. Use conduit to protect electrical wiring from physical damage. Conduit provides a mechanical barrier to protect wires from abrasion, impact, and other hazards. Use cable trays to support and organize electrical cables. Cable trays help prevent cables from becoming tangled or damaged. Use wire connectors to make secure and reliable electrical connections. Wire connectors provide a safe and convenient way to join wires together. Use terminal blocks to connect wires to electrical equipment. Terminal blocks provide a secure and organized way to make connections. Use labels to identify wires and cables. Labels help prevent confusion and make it easier to troubleshoot electrical problems. Use cable ties to bundle and organize wires and cables. Cable ties help keep wires and cables neat and tidy. Use strain relief connectors to prevent wires from being pulled out of electrical equipment. Strain relief connectors provide a secure connection that can withstand mechanical stress. Use grounding bushings to provide a low impedance path for ground fault current. Grounding bushings help protect against electrical shock. Use surge arresters to protect electrical equipment from lightning strikes. Surge arresters divert lightning current to ground, preventing damage to equipment. Use uninterruptible power supplies, or UPSs, to provide backup power in the event of a power outage. UPS can keep critical equipment running during a power outage. Use generators to provide backup power for extended periods of time. Generators can provide a reliable source of power during long-term power outages. Use automatic transfer switches, or ATS, to automatically switch between utility power and backup power. ATS ensure a seamless transition between power sources. Regularly inspect batteries in UPS systems and generators. Batteries are a critical component of these systems and need to be maintained to ensure reliable operation. Follow manufacturers' recommendations for battery maintenance. Use battery chargers to keep batteries fully charged. Battery chargers ensure that batteries are ready to provide backup power when needed. Use load banks to test generators and UPS systems. Load banks simulate real-world loads, allowing you to verify that the systems can handle the required power. Keep accurate records of all electrical work performed. Records can be useful for troubleshooting and maintenance. Use a qualified electrician for all electrical work. Electrical work can be dangerous and should only be performed by trained professionals. Follow all safety precautions when working with electricity. Electricity can be deadly if handled improperly. Continuously educate yourself about electrical safety and best practices. Staying up to date on the latest information can help prevent accidents. Be aware of the potential hazards of working with electricity and take steps to mitigate those hazards. Electricity is a powerful force that should be treated with respect. Report any electrical hazards or unsafe conditions to the appropriate authorities. Reporting hazards can help prevent accidents. Encourage others to follow electrical safety practices. Creating a culture of safety can help prevent accidents and injuries. Remember that electrical safety is everyone's responsibility. By following these guidelines, you can help ensure a safe working environment. Always prioritize safety when working with electricity. No job is worth risking your life or the lives of others. Stay informed about electrical codes and regulations. Codes and regulations are constantly evolving to improve safety. Use online resources and training programs to stay up to date. Attend electrical safety conferences and workshops. These events provide opportunities to learn from experts and network with other professionals. Join electrical safety organizations. These organizations promote electrical safety and provide resources for members. Participate in electrical safety committees. These committees work to improve safety in the workplace. Share your knowledge and experience with others. Mentoring and training others can help improve electrical safety. Recognize and reward employees who demonstrate a commitment to electrical safety. Positive reinforcement can encourage safe behavior. Invest in electrical safety training for all employees. Training can help employees understand the hazards of electricity and how to work safely. Conduct regular electrical safety audits. Audits can help identify potential hazards and areas for improvement. Use a checklist to ensure that all safety procedures are followed. Checklists can help prevent errors and omissions. Implement a lockout/tagout program to prevent accidental re-energization of equipment. Lockout/tagout is a critical safety procedure. Provide employees with the necessary personal protective equipment. PPE can help protect against electrical shock and other hazards. Ensure that all electrical equipment is properly maintained. Regular maintenance can help prevent equipment failures. Use a preventive maintenance program to schedule regular maintenance tasks. Preventive maintenance can help extend the life of electrical equipment and reduce the risk of failures. Train employees on how to perform basic electrical maintenance tasks. Employees can help identify potential problems before they become serious. Use a computerized maintenance management system, or CMMS, to track maintenance activities. A CMMS can help improve efficiency and reduce downtime. Use a condition-based maintenance program to monitor the condition of electrical equipment. Condition-based maintenance can help identify potential problems before they lead to failures. Use infrared thermography to detect hot spots in electrical equipment. Infrared thermography is a non-destructive testing method that can help identify potential problems. Use vibration analysis to detect mechanical problems in electrical equipment. Vibration analysis is a non-destructive testing method that can help identify potential problems. Use oil analysis to monitor the condition of oil-filled electrical equipment. Oil analysis can help identify potential problems. Use ultrasonic testing to detect internal defects in electrical equipment. Ultrasonic testing is a non-destructive testing method that can help identify potential problems. Use visual inspection to identify obvious signs of damage or wear. Visual inspection is a simple but effective way to identify potential problems. Encourage employees to report any unusual noises, smells, or vibrations. These could be signs of a developing problem. Take all reports of potential problems seriously. Investigate all reports thoroughly. Correct any problems that are identified. Follow up to ensure that the problems have been resolved. Document all maintenance activities. Documentation can be useful for troubleshooting and for tracking the effectiveness of the maintenance program. Use a standardized maintenance procedure. A standardized procedure can help ensure that all tasks are performed correctly. Review the maintenance procedure regularly. The procedure may need to be updated to reflect changes in technology or best practices. Train employees on the maintenance procedure. Employees need to understand the procedure in order to follow it correctly. Provide employees with the necessary tools and equipment to perform the maintenance tasks. The correct tools and equipment can help employees perform the task safely and efficiently. Make sure that all tools and equipment are properly maintained. Damaged or worn tools and equipment can be dangerous. Inspect all tools and equipment before each use. This can help identify any potential problems. Replace any damaged or worn tools and equipment. Do not use damaged or worn tools and equipment. Store tools and equipment in a safe and organized manner. This can help prevent damage and make it easier to find the tools and equipment when needed. Use a tool control program to track the location of tools and equipment. A tool control program can help prevent tools and equipment from being lost or stolen. Conduct regular safety meetings to discuss electrical safety issues. Safety meetings can help raise awareness of potential hazards and reinforce safe work practices. Encourage employees to participate in safety meetings. Employee participation can help improve the effectiveness of the meetings. Document all safety meetings. Documentation can be useful for tracking attendance and for recording the topics that were discussed. Use a safety suggestion program to encourage employees to submit ideas for improving electrical safety. A safety suggestion program can help tap into the knowledge and experience of employees. Review all safety suggestions carefully. Implement any suggestions that are feasible and that would improve electrical safety. Recognize and reward employees who submit valuable safety suggestions. This can encourage other employees to participate in the program. Use a safety observation program to encourage employees to observe each other working and to provide feedback on safety practices. A safety observation program can help identify unsafe behaviors and provide opportunities for coaching and mentoring. Train employees on how to conduct safety observations. Employees need to know what to look for and how to provide constructive feedback. Use a safety audit program to regularly assess the effectiveness of the electrical safety program. A safety audit can help identify areas where the program can be improved. Conduct safety audits by qualified personnel. The auditors should have the knowledge and experience to identify potential hazards and to assess the effectiveness of the safety program. Use a safety committee to oversee the electrical safety program. The safety committee should be composed of representatives from all levels of the organization. The safety committee should have the authority to make recommendations for improving the safety program. Implement a continuous improvement process to ensure that the electrical safety program is constantly evolving and improving. Continuous improvement is essential for maintaining a safe working environment. Review the electrical safety program annually. The annual review should include an assessment of the program's effectiveness and recommendations for improvement. Use a risk assessment process to identify and assess potential electrical hazards. A risk assessment can help prioritize safety efforts and allocate resources effectively. Conduct risk assessments by qualified personnel. The assessors should have the knowledge and experience to identify potential hazards and to assess the risks. Use a hazard control hierarchy to select the most effective methods for controlling electrical hazards. The hierarchy of controls prioritizes hazard elimination, substitution, engineering controls, administrative controls, and personal protective equipment. Eliminate electrical hazards whenever possible. This is the most effective way to control hazards. Substitute less hazardous materials or processes for more hazardous ones. This can reduce the risk of electrical shock or other injuries. Implement engineering controls to isolate or contain electrical hazards. Engineering controls can include barriers, enclosures, and interlocks. Implement administrative controls to establish safe work practices and procedures. Administrative controls can include training, signage, and permits. Provide employees with personal protective equipment to protect them from electrical hazards. PPE should be appropriate for the hazards and should be properly maintained. Use warning signs and labels to alert employees to potential electrical hazards. Warning signs and labels should be clear and concise. Use lockout/tagout procedures to prevent accidental re-energization of equipment. Lockout/tagout is a critical safety procedure. Train employees on the lockout/tagout procedure. Employees need to understand the procedure in order to follow it correctly. Use multimeter that meets CAT Roman 3 in/ or CAT Roman 4 rating if applicable. CAT rating is the voltage rating that is intended for the multimeter. Keep electrical equipment clean and dry. Dirt and moisture can conduct electricity. Use a vacuum cleaner to remove dust and debris from electrical equipment. Use a dry cloth to wipe down electrical equipment. Avoid using water or other liquids to clean electrical equipment. Use a non-conductive cleaning solution if necessary. Follow the manufacturer's instructions for cleaning electrical equipment. Store electrical equipment in a dry place. Protect electrical equipment from moisture. Inspect electrical cords and plugs for damage. Damaged cords and plugs can be dangerous. Replace damaged cords and plugs. Do not use damaged cords and plugs. Use extension cords sparingly. Extension cords can be a fire hazard. Do not overload extension cords. Use extension cords that are rated for the amperage of the equipment being used. Unplug electrical equipment when it is not in use. This can save energy and prevent electrical fires. Turn off the power switch before unplugging electrical equipment. This can prevent electrical shock. Do not pull on the cord to unplug electrical equipment. This can damage the cord. Grip the plug firmly and pull it straight out of the outlet. Avoid using electrical equipment in wet locations. This can increase the risk of electrical shock. If you must use electrical equipment in a wet location, use a ground fault circuit interrupter or GFCI. GFCIs can help prevent electrical shock. Do not touch electrical equipment with wet hands. This can increase the risk of electrical shock. Wear rubber gloves when working with electrical equipment in wet locations. Rubber gloves can help protect you from electrical shock. Be aware of the location of overhead power lines. Overhead power lines can be dangerous. Stay away from overhead power lines. Do not touch overhead power lines with any object. If you must work near overhead power lines, contact the utility company to have the power lines energized. Be aware of the location of underground power lines. Underground power lines can be dangerous. Call before you dig to locate underground power lines. Do not dig near underground power lines without first contacting the utility company. If you accidentally dig into an underground power line, evacuate the area and call the utility company. Do not attempt to repair an underground power line yourself. Be aware of the hazards of lightning. Lightning can be dangerous. Seek shelter indoors during a thunderstorm. Avoid using electrical equipment during a thunderstorm. Unplug electrical equipment during a thunderstorm. Stay away from windows and doors during a thunderstorm. If you are caught outdoors during a thunderstorm, crouch down low to the ground. Do not stand under a tree. Avoid touching metal objects. Be aware of the hazards of static electricity. Static electricity can be annoying and can damage electronic equipment. Ground yourself before touching electronic equipment. Use an anti-static wrist strap to prevent static electricity. Use anti-static mats to protect electronic equipment. Avoid wearing clothing that is likely to generate static electricity. Be aware of the hazards of electrical fires. Electrical fires can be dangerous. Use a fire extinguisher that is rated for electrical fires. Do not use water to put out an electrical fire. Water can conduct electricity and can make the fire worse. Turn off the power switch before attempting to put out an electrical fire. Call the fire department immediately. Evacuate the building. Do not attempt to fight the fire yourself unless you are trained to do so. First aid information for electrical accidents is as follows. If someone has been shocked, do not approach them if they are still in contact with the electrical source. Turn off the power source immediately if possible. If you cannot turn off the power source, use a non-conductive object, such as a wooden broom handle, to separate the person from the electrical source. Call for emergency medical assistance. Check the person's breathing and pulse. If the person is not breathing, begin rescue breathing. If the person does not have a pulse, begin cardiopulmonary resuscitation, or CPR. Cover the person with a blanket to keep them warm. Monitor the person's condition until emergency medical personnel arrive. Seek medical attention for any electrical burns. Electrical burns can be serious and require medical treatment. Keep the burn clean and dry. Cover the burn with a sterile dressing. Do not apply ointments or creams to the burn. Take over-the-counter pain relievers as needed. Follow your doctor's instructions. Be aware of the symptoms of electrical shock. The symptoms of electrical shock can include muscle spasms, seizures, loss of consciousness, and cardiac arrest. Seek medical attention immediately if you experience any of these symptoms. Electrical shock can be life-threatening.